Yes, in the previous classes, we have discussed how to forecast the population. We have seen in the last class, we have seen the three methods, right? By how we can determine or how we can populate, how we can forecast the population. This is what we have seen in the previous classes. In today's class, we will be seeing how we can do the problem by logistic method, and then how we can see there are some other methods are there by which we can determine the population, right? So we are into the last part of this particular module one. We will be able to finish this module one in today's class. So we will see how we can do the problem by the your logistic method. Okay, we will straight away we will see the problem by logistic method. Okay, now what is this logistic method, or we also call it as an decreased rate of growth method? Okay, now it is found that the rate of increase on population never remain constant. Now in the previous problems also you have seen that the population is not going to remain constant, but it is going to vary. Okay, now here the population of a city will grow until it reaches the saturation population, right? The population of a city is going to reach, right, to the saturation population which is established, right, which is going to be established. Now all population grow according to this logistic curve method, or by the logistic analysis. So what happens is the population will reach till the saturation point, and then again it is going to decrease. So here what will happen is the population, it is going to increase continuously, and to a certain point due to the some reason, right, we have discussed all what are the different reasons which is going to make the person to migrate. So due to that, what will happen again? The population it might decrease. Okay, it is seen that the rate of increase is going to decrease due to the further reasons. Okay, now we will see here from the logistic curve method, we are going to determine in the logistic curve method what is the saturation population PS. That, yes, just now I have told that the population is going to increase to its maximum saturation value. Now here we are going to determine A and B are the two things that we are going to be determined by using the different formula that A and B. Now what is this P naught? In here saturation population can be calculated by the formula 2 P naught P1 P2 minus P1 square P naught plus P2 divided by P naught into P2 minus P1 square. Now what is this P1 P2 P3 the P naught P1 P2? I will just let you know. Okay, now A, this is a constant that we are going to determine. How we are going to determine is PS minus P naught divided by P naught. This PS is your the saturation population. P naught is nothing but your initial population. Here PS, it stands for saturation population. P naught is your initial population. Now B, how you can determine is 1 divided by n log E into P naught into PS minus P1 divided by P1 into PS minus P naught. So this is, we can determine A and B. Now why we are going to determine A and B? Since if we want the population after so many years, right, after say some n number of years, if we want the population, that can be calculated by using the formula P is equal to PS divided by 1 plus E raised to A plus PT. Now PS is saturation population, A and B are the constant, and T is nothing but the estimated time period. Okay, so A and B are the constant. This is PS is your maximum population that a city can reach, and P is population during the required period of time. So in order to determine the population at a required period of time, how we can determine is by using the formula PS divided by 1 plus E raised to A plus BT. So here we are going to use the two terms A and B. So if I want the population at a particular time, I will require a help of this A and B, two values A and B. So this A and B, how it can be calculated? By using these two formulas, we can calculate the values A and B. Now PS is saturation population, T is estimated time period. Okay, now we will see one problem. If we solve the problem, then the things will be more clear to you. Now we will straight away we will solve one problem, right? A city has a following recorded population they have given the year, right? And they have given the population, corresponding population. Now, the city is having the population of at 1951, right? 50,000 was the population. 1971, 1,10,000 was the population, and 1991 the population was 1,60,000. Now they have asked you to determine, estimate the saturation population. Now you know what is saturation population. It is the maximum limit that the population can reach. Now the expected population in the year 2011. Now this is PS. This is saturation population is nothing but PS, and expected population is nothing but P. Right. So this is what we want to determine. This is what we want to determine. Okay. Now PS we want to determine, and the population in the year 2011 we want to determine. Now, in order to determine PS, right? What is the formula? 2 P naught P1 P2 minus P1 square, P naught plus P2 P naught divided by P naught P2 minus P1 square. Now, what is this P naught P2 P1? Right? As I have told, PS is the saturation population, right? P is the population required during the estimated time, right? Now this is your P naught, the initial population. As I have told, P naught is your initial population. That is 1951, 50,000 is the population. This is what your P naught is, right? Now what is P1? P1 is 1971, right? 1,10,000. This is your P1. Okay. P naught is clear. P1 is clear. Now we will see what is the P2. Okay, P2 is again the third population, that is 1,60,000 is the third population. So this is P naught. This is 1971 population is P1, and 1991 population is P2. So what we want to determine is now the saturation population. Saturation population, in order to determine saturation population, we will be using the formula PS is equal to 2 P naught P1 P2 minus P1 square into P naught plus P2 divided by P naught into P2 minus P1 square. Now just we need to substitute these values in this particular formula, right? We have two. We have P naught as 50,000, so we have kept it over here. P1 is 1,10,000, so we have kept it over here. P2 is 1,60,000, so we have kept it over here. Minus P1 square is how much? 1,10,000 square, right? Into 50,000, right? Into P naught, right? P naught is 50,000 plus P2. P2 is 1,60,000. So we have multiplied it, divided by P naught into P2. P naught is 50,000 into P2 is 1,60,000 minus 1,10,000 is P1 square. So P1 square. So we have got saturation population as 1,90,488. Okay. So this is your saturation population. Then in order to calculate the population population in the year 2000, I think they have asked 2000 or 2011. All right. So we have finished the estimated, we have finished the saturation population, we have finished it. We want to now determine the expected population in the year 2011. So this we have finished, and this we want to do it now. So in order to determine the estimated population during the particular period, we will be using the formula, right? We will be using the formula, right? P is equal to PS divided by 1 plus E raised to A plus BT. We know PS, but we don't know what is A, what is B, what is T, right? So in order to determine that, we will be seeing, right? So here A, we want to determine A, B, and T. So we will first find out A, small a. So log E is into PS minus P naught divided by P naught. So PS is 1,90,000, we have determined it, minus P naught is 50,000, we already know it, right? So we have substituted it. Then P naught. If I simplify it by using the calculator, I will be getting the formula A is equal to, I will be getting the value of A as 1.033. So I have determined the value A. Next, I want to determine B is equal to 1 divided by N log E to the into P naught into the bracket PS minus P1 divided by P1 into the bracket PS minus P naught. So this is the formula, but we don't know what is the N. Here I have written N is 20. So what we will see that. Now, what is N is equal to 20? Now, what is this N is equal to 20? The difference between the two successive right? Two successive decades. This is, they have two given the two decades. So number of successive decades. Okay. So 1951 to 1971. It is right. It is number of years. It is number of years that they are going to count. N is equal to number of years. So 19 between the two successive decades. Okay. So 2 year. This is 20 years. 1951 to 1971. It is 20 years. So here we will be writing this value of n as 1 divided by 20. So n is nothing but your number of successive decade. N is equal to n is nothing but your number of years. What I think it is understood. Yes, is it understood? What is n?
Yes, sir.
Yes, is it clear? Okay, shall I go? What is n? Is it clear? What is n? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. So I'll go ahead. V is equal to 1 divided by n log e p naught into ps minus p naught divided by p1 into ps minus p naught. So 1 divided by n is 1 divided by 20 log e. P naught is, you know, it is 50,000. Ps, we have calculated it as 1,90,488 minus P1 is 1,10,000 divided by P1 1,10,000 into the bracket 1 lakh Ps 1,90,488 minus P naught 50,000. So B value we will be getting as minus 0.0673. So B we are getting in the negative term. Okay. Now what we want the population in the year 2011. So we will be substituting whatever the values we have got. Now PS we already calculated it is right 1,90,488 divided by 1 plus e raised to a is how much 1.033. We have substituted it over here minus b into t. B we have calculated as 0.0673. So we have substituted over here into t is 60. Now what is this 60 is? Right. Now what we want the population in the year 2011. But from when? We want it from 1951. So here if you see 1951 to 2011, right? How much is the difference? So that difference is nothing but t, the population in the year in the required duration of time. So here t is nothing but the difference between the population what we want minus the initial population. So t is nothing but it is 60 years. It is nothing but the 60 years. So we are going to substitute all these, right? We are going to substitute all these. P is equal to PS is 1,90,488 divided by 1 plus e raised to a, that is we have determined it 1.033 minus bt, right? Plus it is, but since we have got b negative, we are getting over to here we are going to get the negative value. So we are going to get it as 0.0673 into 60. T is 60. This is what we have determined it. So if we simplify it, we are going to get the answer as the population in the year 2011 we will be getting as 1,81,500. Okay, 1,81,500. So this is how we are going to solve the problem by using the logistic curve method. So here, first step by step, I will tell you. First, you need to determine the saturation population by using the formula. Then, if you want to determine the estimated population, you need to determine what is A and B, because if you want to determine your population in the expected duration of time, you want PS divided by 1 plus e raised to a plus bt. So if you want to calculate this expected population, you need to find out a plus a b, right? So a and b you need to have utilize these two formulas, right? This one is for a and this one is for b. So you need to substitute all these values and you will be getting a and b. So t is the difference between the expected population minus the initial population, that is t, right? So this is how you are going to get A, B, and T. Then to determine the expected population, you will be using the formula PS divided by 1 plus E into to the power A minus plus B into T. So by you substituting all this, you are going to solve the problem. Is it clear?
Yes.
Yes, is it clear?
Yes, sir. Yes, sir.
Yes, sir.
Is it fast or it is understood? Yes.
Bit
Is it
fast.
understood? Huh? Is it fast?
Bit, sir.
bit fast. Have you understood? But
Yes, sir.
Yes, sir. Understood.
Yes, sir.
is there any problem in understanding? If it is fast, okay, but fast but not understood is not okay.
Understood, sir.
Yes, sir.
Okay. Then shall I go ahead? Shall I go ahead?
Yes, sir.
Yes, sir.
Fine. We will see what are the different. See, these four methods, that is your increment method, arithmetic increase method, geometric increase method, incremental increase method, and your logistic method. These are this one. Uh, we will be solving the problem. Please keep your mic mute. Please keep your mic mute. Okay. So here, what is happening is we will be using the four methods, that is the arithmetic increase method, geometric increase method, incremental increase method, decrease growth rate method, or the logistic curve method. We will be solving the problem on these. Now, these are the different methods where we are going to have in the population forecasting, but the problems we are not going to get on these particular the method. Or okay, so here we will be solving an arithmetic increase method, geometrical increase method, increasing increase method, decrease rate method, and logistic curve method. By these five methods, we will be normally getting the problem. Remaining one, we will just see what it is. Okay, we will just see what it is. Okay, geometric increase method over, right? And then incremental increase is over. Then we will have seen the decrease growth rate method. Now we will see the comparative graphical method. We will see it is just for understanding thing. We will be seeing what is the your comparative the graph method or the graphical extension the method. Okay. What is this particular method says? Okay, what this particular method says is, right here. In this method, the city is having condition and characteristics similar to the city whose future population is to be determined, estimated first are selected. Right here, the population, the city is having conditions and characteristics similar to each other. Right, they will be determined first. It is selected. Then it is assumed that the city under consideration will develop with the selected population developed in the past. This method is logical background and it is going to be it is development of the similar city, and then it is going to be results can be obtained. Now what we are going to do is, right, we want the population of the successive the years decades. Then what we are going to do is we will be determining the population at say 19 your required population that we are going to the determine. Okay, so here this in the graphical extension method, right, it is going to have the plot between the population and the time. Here it is going to have the graph of the population versus the time. The dotted portion is a curve, right? The dotted portion, whatever I am going to I have extended, right from 19 your right from your 1991 to 2011, right? 1991 to see dotted portion A, B, C, and D. So what is A? A is for 2000, B is for 1960, C is for 1955, 1965. So dotted portion, it is going to follow the close trend, okay, from the extended part. So here we will be having the possibilities of the future expected population, right? A, B, and C and D. So here we are going to have these kind of expected population, and we will be seeing now the population of a city A, right, under consideration is plotted up to 1970. Now this is the A city population. It is how much? It is 62,000, right? A is we are determining it as 62,000. From 62,000 we have increased it. The population of city B, right, it is going to be in the year 19th we are going to have from 1930 onwards. So here this is how we are going to estimate the population by the different methods. Now Next method is master planning method or the zoning method. Now, uh, big and metropolitan cities are generally allowed to develop or in a planned way, and their expansion are regulated by the various plans or by the corporation. The master plan prepared for a city is generally it is to divide the city in the various zones and to separate it from the residential and the industrial areas. So here we are going to calculate the population of a city by the different master plan method or by the zoning method. Here we are going to divide the population into the different zones, and then we will be calculating the method. So this is what your logistic curve method is. This is what we have explained just now by the logistic curve method. So this is how the different methods is going to help you in order to determine the population. So for first five, that is your arithmetic increase method, incremental increase method, geometric increase method, decreased growth rate method, and the logistic curve method. This is, on this we will be solving the problem. See, we have solved some of the problems, right? In addition to this, you also need to solve some problems from SK Garg also. So we have solved the problem from BC Punmiya, right? You need to solve the problem from SK Garg. See, the problems, it may come from any of your the textbook. So we need to solve the problems from both the textbook, and you should be well versed with the problems. So here we have finished, I think, all topics, right? All topics of module one. So we will just cover one per capita demand also we have completed, but still we will revise it, right? The per capita demand, it is nothing but annual average amount of daily water consumed by a person, or how much amount of water that the per person for a year he is going to consume. So it is per capita demand is we are going to have it as the total yearly water requirement of a city divided by 365 into the design population. So this is how we can calculate the per capita demand of a city. Okay. So here this we have already seen it. Then factors affecting per capita demand we have seen it, right? All these things we have already covered. Okay. Now we will just see what things yet has to be covered in the module one. Right? In module one, what are the things that has to be covered? We will see it. If anything has been left out, we will cover it, or else we will end the module one over here.
Sir,
Yeah. Tell me.
sir, do you have PDF notes, sir? The handwriting is not visible in laptop or mobile.
I will send it. I will send it. Don't worry, I will send it. I will send you the notes also, but in addition to that, only notes is not sufficient. Right? You also need to follow the textbooks also. Right? Do you have collected the textbooks? Have you collected?
No, sir.
No, sir.
Right now, I will give you the notes, but you should follow the textbook also. Okay. Right, because the notes, it is I've done it, but you, for extra information and all, you need to follow the textbooks also, because the textbook is going to give you complete information, right? So we will see what has to be covered. If anything is left out, we will see it, right? Need for protected water supply, we have covered it. Demand of water, right? Types of what is demand of water?
Done,
We
sir.
have types of water demands, that is domestic, industrial, institutional, commercial, public use, fire demand, right? Factors affecting per capita demand, variations in water demand with having the thing peak factor we have covered, right? Then design period, what is design period, we have covered it. Then factors governing the design period we have covered. Then the different methods of population forecasting. So I think entire things has been covered, right? Yes or no? Yes.
Yes, sir, covered.
Okay. So here module E1 is going to be completely finished. In addition to this, right, you need to follow the textbook notes. I will be circulating in your group, right? But in addition to that, you need to follow the textbook also. The textbooks that you will be referring is your BC Punmiya and SK Garg. So module one is, it is completed. I will ask you few of the questions, right, so that you can answer. Right, we will be taking some of the questions at the end. Right? Can anybody tell me what is the demand of water? Water demand. Yes. What is water demand?
Need of water. Need of water.
Need of water. What are the different purposes for we require water? Water demand. What are the different types of water demand?
Domestic, industrial, and commercial.
Okay, institutional, public use,
Fire fire demand is
fire demand, right? So these are the different uses of, or these are the different water demands. What are the factors that is going to affect the water demand?
rainfall,
Okay,
Climatic variations.
okay. Hmm. Then size of the city, right? Living standards of the city, water losses,
population,
pressure in the water supply line.
population.
Yes, population, right? Living standard of the people, right? All these will be necessary. Then we will see population fire demand. We have seen the different formulas. Then factors affecting the variation in demand we have seen. Okay. Now, what are the different methods in order to determine the population forecast? Different methods to determine the population forecasting. Yes,
Arithmetic increase method.
good. Then,
Geometric increase method.
then,
Logistic method.
Incremental increase method.
good. Okay, arithmetic method, incremental increase method, geometric increase method, then a logistic curve method, decreasing growth rate method, then a zoning, right? So these are the, and then the graphical extension method. So these,
Decrease growth of increasing.
yes, so these are the different methods by which we are going to determine the population. So this is what we have studied in module one. Module one, you will be facing the problems on the fire demand or population forecasting. So it is like 60-40 type of a question from module one, right? You will be getting with the need sketch. You will be the possible questions. I will tell you what is the need of protected water supply, right? Then what are the different types of water demand? Explain what is water demand and the different types of it, right? And then what are the factors affecting the per capita demand, right? And variation with the need sketch, explain variations in the water demand, right? Then what is design period and factors governing it, right? So this is what the theoretical questions you may get, and you will be straight away you will be asked the problems in straight away you will be asked with the problems, right? So this is what we have seen in module one. So your first module one is completely over. We have completed the 20% of the syllabus. Is there any questions? Yes, is there any questions?
No, sir.
Okay, so from next class onwards, we will be entering into very important aspect, that is module 2. Here we will be discussing regarding what are the different sources of water, what do you mean by sampling, what are the different preservation technique and the different water quality parameters, and what is an here onwards we will be seeing about the water treatment thing we will be seeing right from intake structure here, where water treatment flow diagram we will be entering into. Okay, so module 2 is also there will be a few of the problems will be asked, right? And then we will be seeing some of the Bureau of Indian Standard, what are the drinking water quality standards and all that we will be seeing in this particular module 2. So again, it is going to take around 8 to 10 classes for module 2 also. It is quite big. And then module 3 again, the extension of module 2. All these things will be there. We will be studying the module 2 in the next class. Is there any doubt? Shall we end the class? Yes.
No, sir. No doubt, sir.
No doubt.
Yes, sir.
We'll end the session.
Yes, sir.
Yes, sir.
Fine. We'll do the next class. Thank you.